Okay, I'm kind of tripoded here. Not exactly a professional setup, but figured I'd go ahead and show you the soldering process. I want to put one of these weatherproof ends on. This is a 3-terminal. Plug into that. But you basically, you got these little metal pieces. It's got the wings so that when you push it in, it catches. It's got the little weather part that you push up. Now these are actually 12 to 16 on these. It's hard to find them much smaller, but you can still get this to fit. This is a little looser, but what I'll do, I'll roll a little bit of tape on there to build up the insulation, and then it'll give it a much better press fit. May even put a dab of silicone. We'll see how it turns out. But I did roll the back here to give it a good grip on the insulated part, and then I was able to flow some pretty good solder. I decided not to bend in these teeth. I think it's overkill, and for future maintenance it would be easier if I just left it like that. It seems pretty solid like that, but that would be optional if you want to do that. So I'm using my Willer. Oh, what's my model? If you need a salt, your little AutoZone $10 soldering iron will work. I like a temperature controlled. I use the Willer WESD 51, and it's got a temperature control. Now granted, you're probably better doing this without it connected, so there's no circuits that could overheat from the heat backflowing into the circuitry. But I mean, these are thin, they're aluminum, they heat up pretty quick. I'm going to go ahead and leave it on. But the first one went pretty quick. I'm going to see if I could try to get the tripod in a way that you can see this. Maybe it'll help somebody if you don't have a lot of solder experience. But I basically just used my wire splicers. Use anything you need, just get it spliced off. This is an 18, and again, that harness is the standard. Part number is S956. So let's see here. Now, one thing I didn't like about these terminals, look at the size of that. I mean, I probably could have clipped it down. I just kind of rolled it. But, I mean, that's kind of overkill, even if you got 12 gauge wire. I've never seen them quite that big. But what I did, and again, this is going to be a little hard. I got a camera in front of me. I came in with my needle nose, my long nose on the edge. See how I just kind of rolled that in? I'll try a little more. And then I'm going to just gently push it down. See how I did that? And what you want to do is make sure, and I'm going to go ahead and slide my weather seal on there first, because it's easier to do that first. Now, when I put my wire through, yeah, see, I got lucky again. I made it just tight enough that I got to push it in with some pressure, but not that much. And I let maybe a 1/16th, go past, so it kind of squeezes it and helps it not want to snag out. Then I'm going to come back and I'm going to roll this one very tediously. See how I'm just playing with it and working it? I don't want to squeeze too hard because I'm trying to not make this get too out of round. If you make it too flat, it may not fit very good into the holes. Or it may fit. I don't know. I haven't looked that far into it. It's how I do it. But if you just keep playing with it, you can see how it's starting to roll around there pretty tight. Then when I get it close, kind of like I am, let me get it a little more. A lot easier without a camera in your way. Now I'm going to start, I just keep working around, making it tighter and tighter. I'm giving it more and more pressure. And I'm trying not to flatten it, and if I do, then I offset it. Now, as you can see, that's in there pretty good. I actually want to give that just a little bit more right there. She's in there pretty good. I'm giving it a good little tug. So now what I want to do, I'm going to set it up. I like to use a stone for this. I mean, I guess, you know, I have a contraption that could alligator clip it and hold it. And I don't know, I just like using the stone. So I'm going to take my solder. Now, personally, my preference, I like Kester leaded solder. And this stuff's getting harder and harder to find. This is the stuff that the EPA is pretty much banned. The thing is, though, it flows so nice and you don't need as much heat. You know, the new tin requires a real high temperature threshold to get it to melt. And in this scenario, the quicker it melts, the easier. But that's what I'm using right there. Stuff's good. So, I already got a little piece left over that I snipped off from when I did the first side. So what I'm going to do, now that I got it kind of in there, I'm going to come in and I'm going to get a position and I'm just going to hold it down. See, this would have been easier if I didn't have the camera, because last time I was able to switch hands because I'm righty and I'd rather flow with my right hand. But now as that tip is touching it, it's going to radiate heat. And see how I'm touching it and it's not melting yet? It's kind of important to do that frequently, because the longer you go, the more heat that is sinking back into it. And if you go too long, you can actually start melting the insulator. But, okay, I'm already starting to flow. Hopefully you can see that. I know my left hand's hurting the light. I'll try to angle it. But, there you go. See how I'm just flowing it in there? I'll get a little bit more. And then take it away. And it'll be warm. You'll feel the warmth on your fingers even through it all. I'll blow it a little bit, but there you go. In that kind of orangey color, that's the flux core. Kind of like welding, you know, you either have to use shielding gas or you have to use like a flux core that basically primers itself. It preps the surface. Not that our surfaces are dirty, but it could have finger oil or whatever. But at any rate, I just figured I'd show you that, you know. Then you get the terminals on nice. You know, it's all soldered in and you don't have to worry about corrosion. Even though they're weather tight connectors, it's still nice to kind of not have to worry about the corrosion, you know. And then when I go to put that on, it'll basically push in, snap in. You know, you'd be able to see it coming out that side. And then again, you would just take this grommet, this weather proof and grommet, and then push it all the way up and call it a done deal. Okay, so now at this point, I have all three of the ends on. I just want to go back and say for my oiler, I don't know if I said the temperature. The highest temperature is 850. So again, I'm not dealing with a sensitive, transistor or resistor or diode or whatever that I worry about damaging the components. So I'm doing max temperature. I'm just trying to get it to flow as quick as possible and wick up a lot of heat on the tip before it heat soaks out into the wire too fast. And again, I'm choosing not to crimp these in. It's easier for future maintenance, and I like that I can really puddle up the solder all kind of in there, giving it a really good connection. Another thing I want to add, make sure when you do that, when I splice the end off, of course, you twist it, you get it nice. You want to flow enough solder that all the copper, or I guess if you're using aluminum wire, all that wire is coated. And that's going to help you with corrosion down the road too. It'll give you a nice solid, conducting path. But now, I'm sure there's probably a better way to do this. Well, I guess the better way would have been finding the connectors that were the right size, except for the wires I'm connecting it to are going to be 12 gauge. So that's why it benefits me to kind of use this. Oh, I got to look over the camera here. I'm going to use Scotch tape. Electrical tape would probably be more ideal. It better takes temperature, engine temperatures, but it's also a little thick when I tested it out. So I'm just going to use this Scotch tape. I'm going to keep it, of course, as tightly wrapped as I can. Okay, now let's see if I built it up enough. And that's something too, where if that tape fails, I can always come back. Actually, that kind of fits over the end. That helps a little bit too. We'll see when we put it in there if I can actually push it that far. But that works out nice. See how that fits over the end? I'm going to put one more layer of Scotch. I'm doing about 1.5 inches at a time here. And again, comment, if you think of something that's better, that's more durable for, underhood engine temperatures, that's, thin like this and not super thick like electrical tape. Okay, I have a feeling that's going to do the trick. I didn't wrap that last one quite as nice, but that's what I get for looking through the camera when I do it, right? Okay, let's see. Fortunately, our solder's bonded good enough. Yeah, see now how that takes a lot of... That's what I'm looking for. I got to really work it. Now I know moisture is going to have to really work to get in there too. And if it does get in there, the solder basically made a barrier through all our threads, our threaded wire. So, it can't corrode inside the wire that easily. So I think we're in good shape now. And I think what I'm going to do, I'm going to try popping one of these in. Actually, let me just pause because I want to make sure I pop it into the right... that's what I wanted to show you. The main reason I'm doing this is because I want a quick disconnect, because where this oil pressure sensor is located on my vehicle, it's not easy to get to. And this harness fits real tight. My first sensor was an AC Delco sensor, or sending unit, pressure sensor, switch, whatever you want to call it. And an AC Delco on the rubber. And then, of course, my new switch is a intermotor. And the harness is that standard. I think I already showed you. But it fits a little bit easier than the AC Delco. I actually had to use some Vaseline, which I didn't like doing, to get this to slip on. This one I was able to get. I mean, I really had to fight it. I mean, just to show you here, it's not even the easiest to take off. You know, I got to walk the dog back and forth. There we go. And bend one of my terminals, which will make it that much more fun to get on. But what I'm going to do, I'm going to label. Like, that one's my S terminal, that one's my P, that one's my I. And whichever one corresponds, like when I look into this, the light's kind of bad, but I'll put it to where, see that top hole? That top hole is going to be the S, okay? So just to be safe, I want to make sure my middle wire goes to the top hole, which it should. So I'm going to do a continuity test. Okay, I grabbed my meter. What you're going to want to do, get all the pollen off it. Thank you, springtime. We're going to put it down to the continuity beat. And we're going to verify everything goes where we think it goes. Because even though it logically should, trust me, I've seen it not do that before. So you would think the middle one should go to this upper middle. So just to check it, see, we got our continuity beat. I'm going to go ahead and take the middle wire, clip it, and of course when you're doing a continuity check, it doesn't matter your polarity, black, red, probe either one. Now we should beep. I wish you had better light there, but I'm on the middle one. So we know that's good, right? And again, it should be, but I've seen things get goofy. So now if that's the middle one, and that's the top, now we're going to do it to the middle right. So I'm going to switch it over just to make sure the right and the left don't, for some goofy reason, get switched in here. And it shouldn't. But I'm telling you, I've seen goofy stuff happen, and you don't want to do all this work and then be like, damn, you know. And we're golden. Good. So we got the continuity out of the way. So, depending on what kind of switch you may be wiring this for, sometimes the terminals are marked, sometimes they're not. Either in my other video or part of this video, I'll show some of the other type of pressure sensors that you can use, and you'll see that they're a little bit different. You know, which terminal does what and how they're labeled. But that middle one's S, so I think it's a good idea to make yourself a, you know, some masking tape, put S on there just so you remember. You know, and I would look at it as middle, with middle being on the top, left and right. Which, of course, you know, is different depending on if you're looking at it that way or, you know, coming off it reversed when the harness is on there. But now that we know our middle's our middle, let's try putting the middle one in. Let's see if what I did worked out here. So, I'll fish out my middle one. Oh, I guess I can't do my middle one first because I didn't tape that one yet. So let's see. That would make it my right one with it on the top. I'm going to make this represent the top, the clip. So that would mean I want to have my right one. Hold on, let me make sure I do that right. Like I said, you could get reversed. Yeah, that's going to be my right one looking in. But because this faces away, there we go. Just like that. And it works. We're locked in. I'm going to use a little flathead to just kind of tuck down that weather strip a little bit. There you go. And then, of course, if you want to be real precautionary, you could go back to your continuity, which I would recommend this. Every now and then things go wrong. Stick it on your terminal. There you go. I would check all of them when you do that. Okay, now on the other side of the spectrum, there's the 12 gauge wire. So the harness that I'm building, that's, going to go to the rest of the engine compartment, I'm going to use 12 gauge. Even though it's overkill for some of the circuits, like the switch circuit, it's more durable, so I'm going to go with the heavier gauge. And again, the added resistance of the extra coppers, not going to be an issue for this circumstance. So probably would have been better if I showed you with the blue grommets pulled back, but you can kind of see. You don't get quite as perfect as a twirl as you do on the smaller wire, but it's the same basic principle. But my left two wires, they came from a guy on eBay, and it was actually a little thicker. And I don't know if you could tell, but I had to leave a strand out on each one. And then my yellow is just your typical O'Reilly's yellow wire, and that one slid right in. So the eBay stuff I used was a little bit thicker. Also, the O'Reilly's was, like a true rubber-based jacket insulator. And the other stuff was that hard PVC. So the price was right. I got that stuff for, I want to say $11-12 for 25 feet. And then I didn't have to use the orange. That's actually going to go for my relay to the fuel pump circuit. But I'll go ahead and post where I got the wire right now. Then if anybody's interested, you got my link. Okay, after I have all three assembled and pressed in, the first thing I did was I labeled them. And again, usually these will be labeled. Sometimes they're not labeled. If they're not, I just pick this to be top, and then that becomes T, and this becomes L for left and R for right. In that case, you just got to remember your T's top. But you could make it B for bottom. It doesn't matter, because as long as you have a T or a B, you're going to know which one's left and which one's right. I just used some white tape and kind of did that one a little bad, but it doesn't matter. Before I hardwire everything in, everything's going to be connected with spades and jumper wired to make sure it works anyways. So this just makes it easier to know what you're doing. Then I take this and I tape these together just to give it a little more stability from snagging. When it's all said and done, I'll come back with that split plastic black conduit stuff, to shield the wires, and I'll put that over. So one final thing I like to do, okay, even though as we were going along, we were checking and we had good continuity, I like to do a final check. And what I like to do, terminal by terminal, this is the center terminal, or at least it should be. We have continuity, right? I wiggle it just to make sure you're not going to have, something that's on the edge of failure. I don't want to over wiggle it and hurt the integrity of what I just did, but as you can see, that's still durable. Then I'm going to move it to my left one here. I'm going to do the same thing. Notice I don't have any breaking continuity. Rock solid connection. And I'm going to do my right one. And of course, when I look at this, it's my left one, but it would be my right if I was looking at it that way. So I know I can trust that. Then when I go to hook this up, when I make the rest of the harness, it'll be good to go. Nice and weather tight.